For this example, we're going to determine whether a function is linear or nonlinear when we're given a table of values. And then if it is linear, we're going to write the equation for the line. So we have this this table of values here, and we want to know, is it linear, right? If it's linear, then that tells us that the average rate of change, the change in y over our change in x, will be constant. So if the change in y over the change in x is constant, that tells us that it's linear. So what we have to do is look at how are the y values changing, how are the x values changing, and if that change is constant across our entire table of values, then we know that this is linear. So to go from 4 to 1, we subtract 3. To go from -2 to -1, we add 1. So the change in y over the change in x here is -3 over +1. To go from 1 to -2, that's again subtracting 3. To go from -1 to 0, we're adding 1. We're actually adding 1 in all of our x values. We can see that it's just increasing by 1. So our change in y over our change in x here is again -3 over +1. Now you can't just stop if you see that two of them work, because maybe there's some change in the pattern later down the road. So to go from -2 to -5, again, that's subtracting 3. And then from -5 to -8, again, we're subtracting 3. So we can see that all of our changes in y over our changes in x, are the same value, -3 over 1. It remains constant. So what that tells us then is that this function is linear. It's linear. So now we need to write our equation. How are we going to do that? Well, this change in y over the change in x, that is just the slope, or our average rate of change for this function. So we know the slope. So to write our equation, f of x equals mx plus b, all we need now is our y-intercept. But if you remember, y-intercepts have the ordered pair 0, comma b. So do we have an ordered pair with an x-coordinate of 0? Why, yes, we do, right here. So our y-intercept is 0, -2. We know our slope, right? Our slope is -3 over 1. So we can write our equation. So our equation is going to be f of x equals -3 times x, and then b is -2, so -2. So this right here is the equation for our line. Again, for this example, we want to determine whether the given function is linear or nonlinear, and if it is linear, we want to write the equation for the line. So again, for all of these x values, we can see that they are increasing by 1. We're just adding 1 to every single x value to get the next x value here. So really, we know that for all of these, the change in y over the change in x, we can see that our change in x is always +1. We need to know, is the change in y always the same? So to go from 2 to 3, we're adding 1. So it's +1 over +1. To go from 3 to 6, it's +3. To go from 6 to 11, it's +5. To go from 11 to 18, it's +7. So we see that there's a pattern here, +1, +3, +5, +7, all over 1. But even though there's a pattern, it's not the same average rate of change, right? It's not increasing by the same amount in the y's over the x's, and it's not remaining constant. So because of that, we can say that this function is nonlinear. It's a nonlinear function because the average rate of change is not constant. So the slope, right? The slope or average rate of change is not constant. Not constant. So it is not linear.